Okay, so for this part, I'm going to, again, kind of similar to what we have in the project, is to do some calculation, okay? And I'm going to calculate the grade, and I'm going to return the grade back as either A, B, C, D, or F, right? Depending on the grade that's received in the course. So this would be very similar to how you would calculate your calories in the program, okay? So I'm going to create a new function here to calculate the grade, and what I'm going to do is that when I get the grade here, I'm going to pass this grade to the function, and then it's going to do some, it's not really calculation, but we could, if we have like multiple grades, you could take the average and so on. But let's assume that we already got the grade here, and we'll just determine what type of grade the student should get. Okay, so I'm going to pass the grade to the function. Maybe a function could be something like down here, we'll say, I'll put like a string, maybe like final grade or something, and we'll have the function called calculate grade. I'm going to pass the grade to that function. Okay, and then the grade here would be like grade for the course. We could say like course grade. Well, I have another statement on the bottom here. We'll have like a final grade or something. So final grade, and this will be the final grade, which is A, B, C, D, or F. And it will be returned by the function. Okay, so let's create a function called calculate grade. So I'll put it right here. It's gonna be a static. Return type will be a string type. Okay, because it's going to be A, B, C, or D, right? Or you could have it, so if we return a character type is fine too. It doesn't matter. But we can use char, it's fine. Since we haven't used that for a while, actually, I haven't used it yet. The calculate grade method, it's going to take a grade of double. And then this is part of chapter 5 here. Okay, did I do something wrong here? Oh, return, okay. So when we receive the grade, whether it's between a certain range of numbers, then we'll return that grade letter back. You know what, I think it's not going to be a character, because we might have an A plus, A minus, right? It's a 2 characters, so it doesn't work. It has to be string type. So I'm going to do the if block, and again, this is like in chapter 5. Okay, so this is the if else. So I'm going to check for the grade. We'll say if the grade is greater than or equal to, we'll just say 97, then we should return a letter grade of A. Okay? If it's above 97, including 97, that's inclusive. So else if, okay, you do the second if block, and then the condition will be like, I'm going to check the grade again. If grade is, how do you say, between maybe 94 and 96.999, right? So how would you do that?
94 less than sign grade 96.99.
So you can say if grade is greater than 94. Okay, that's one way, and
and then you gotta do the other side.
yeah, you can say and, right?
Yeah.
And grade is between 94 inclusive and less than 97. Okay? Because the less than means not including 97, so all the way up to 96.9. Then you wrap those two like that, right? So that range, if that's the case, then we return, say, A minus. And then we'll do the same for the rest of, let's just say I'm going to do just 3 more. Between 90 and 94, then that's B plus. And then between we just say 85 and 90. Then you got B, and else we don't have any other grades. Return F. Okay? I'm pretty strict here. B minus is not acceptable in this class, right? So let's say we do that. Okay, so let's run this and see what happens. See if it works. Okay, so we have, right? So first student is 97.5, so that's an A. That's good. Larry has 95.5. That's A minus, which is also true between here. And then Joe has 89.4, so he got B. And he's lucky he survived. But anybody below that will fail. Okay, so as you can see here, the way this is structured, because these if blocks will be executed from top to bottom, right? If you put the if true, else, if do that, else, if do that, then it means that only one of these lines will be true. Okay, so what happens if the first case is not true? It's going to jump to the second part, and if this is not true, right? Then keep going until it finds the else part, right? Okay, so instead of doing this way, why don't we just do that? Does it make sense? I don't need to test the upper bound because it's already tested here, right? If it's 97, then that's going to be true. If it's below 97, but above 94, then that's true. So this means from here, if it's 97, then this will be A, we're done. If it's 96, this is false. So it's going to jump to the next one. Is it above 94? Yeah. 96 is above 94, so it's true. Right? So you don't have to test the second part in this situation because it's always from top to bottom. If the first one is false, then the second has to be true in this case. So same thing here. Anything between 90 and 94 is true, so I don't have to do this part. Okay? So these are all redundant. Shortcut, right? Again, just to make you think, how is that possible? Yeah, it does work this way. Okay? So if I save this now, and if I run, I should get the same result back. Okay, so A minus, and then B. And just to be sure, let's just say we put one right on the board, like 84 or something. Let's just say Joe got 84. Okay, and then we run this, and then we see that Joe he failed the course. Okay, so right. So when you get to these type of conditions, it really kind of makes you think. I mean, it's not wrong to have you had it before, which is fine, and sometimes it's easier to see it that way, which is okay. Okay, but the confusion is sometimes you would say you just want to make sure that you have the right block here. You don't want to say if this is greater than that and also greater than or equal to, less than or equal to that. Now you might have a problem, right? You might run this situation where you have a redundant C in the code. So just gotta be careful when you do your code. So either way, it's fine. That is fine too, but this will be shorter. And you'll see that if you for a veteran or experienced programmer, they will do it this way. Okay. So that's using the if and else block. Okay, so by the syntax is if, and then you always wrap the condition inside the parentheses here. Okay, if a condition is true, you will test it using those operators, the greater than, less than, or equal sign, right? So that's these, I think it's like 84. I lost it. Here, right here. Okay, so you can use this less than, greater than, equal to, not equal to, equal, the equality sign, not equal. Okay, so these are pretty straightforward. We only kind of use this in chapter 2 if you remember the data type. So the one that we didn't use are these three down here. The ampersand, the logical and, what's the logical or, the two pipe symbols, and what's called the conditional, or sometimes you hear the term ternary operator. Okay? So let's see how that works in the case here. So I have here, this is the ampersand. Okay, this is an example of a logical operator. Logical, we call it AND operator. Okay? It tests for both conditions in this case. Both has to be true in order for this to be true, right? If we do it this way. This is also called, sometimes you call this the, they put up here, logical operator, or sometimes called the short circuit operator, okay, or short circuit AND operator. Okay, what that means is that it's like a short, if you think of it like a circuit, right? You have two circuits here. In order for this, both of these to be true, this has to be true and that has to be true, right? So the AND is that if either one of them is false, then the whole result is false, right? Are we familiar with the truth table? True and true is true and false. If you AND it, will be false. So for the AND, if you have if this is false or this is false, then the entire result is false. So for the AND, using the short circuit, it means that we're going to test this from the left to the right. So the first case, if this is true, then that's good, so it's true. Then we also need to make sure that, so here, if this is true, right, then this has to be true as well in order to be true. But we don't know that yet, so we have to test the second part. So if this is also true, then the whole result is true, right? The result is going to be true. Okay? If it's false, if the first part is false, right, then it doesn't matter what the second part is. It's going to be false anyway. So this part is not going to be checked. It will skip it. That's why it's called a short circuit. Okay? If it's false, then you don't need to check this. And so don't spend any additional CPU time and validate this. You don't have to. If it's true or false, it doesn't matter. There's only one false, so the whole result will be false anyway. Okay? So that's the short circuit for that. The other one is the OR, which is the double pipe symbol. This is the logical OR. The logical OR is, that means that as long as, it's just the opposite of the true, right? If either one of those is true, then the whole thing is true, right? So, well, let me just do this. Let's put up here. Back here we'll say, if that is true and, or we could say if grade is less than 94. Okay, we said that before. So this is the logical OR operator, or again the short circuit OR. And then again, this would be like if this is true, or if this is false. If this is false, then we need to check the second one. Okay, because if it's also false, then the whole thing is false. Okay, if this is false, and again we have to check the second one. If that's true, then we get a true, right? If this first part is true already, then we don't need to check it here. We just leave it out, and we'll get a true anyway. Okay, so so you have those three cases. Of course, you have a true and true, which will also be true, right? But this is how it's actually worked behind the scene. You don't get to see it, but this is how he does it. okay, the short circuit. So it will compare the first part if it's for the OR. If it's already true, then you don't have to do. Because you might have something like this. You might have like this, right? Have a lot of those conditional operators together, and then if it's any one of those is true, then the whole thing is true, right? So in that case, you don't have to test everyone, okay? As long as one is true, then you're good to go. And then same thing with the operator and here. Imagine you have like 20 of those, right? Usually you don't have it, but it can be like that, okay? And so it just consumes CPU times, and this is how you would use for the operators to compare to combine two if blocks together. So right here, for example, this part here, we use the logical AND here to combine two conditional statements together. This can also be written as what? How would you rewrite this? So I can have what's called a nested if, okay? If that is true, right? So you would do something like this. We'll do one down here. Else, if, let's say if grade is greater than 80, if that is true, okay, then we have a nested if block in here. Now I need to check if grade is less than 85. If that is also true, then return B minus. Okay? So this is an example of what's called a nested if. Another if block inside here. Notice this one doesn't have the else part. Okay, I could have it, but in this case the else is not needed because it doesn't matter. If it's not true, then it's going to skip out. Well, actually you have to return a grade. If it's less than that, and if it's greater than this, return a B minus else. I think else is going to return the F again, right? Because it's either there or not there, for example. But so you have a nested if inside another if here, and if you look at this, if grade is true, then you also want to check the upper bound, right? Only you check here if the first part is true. Otherwise, you will skip the whole thing and jump down here. So you have a nested if. And by using nested if, sometimes it's crucial. Sometimes you can use it to combine it together and use the ampersand to combine together this way so you have the same result. Okay? So it does the same thing, except you have you break it down so you can see it, I guess, differently. But so either way, it's fine. So if I ask you an exam, I have a nested if like this. Can you write this in using the ampersand as a logical to combine these two compound logical statements into one? So can you do it, right? So this is how you would go back and forth between the two. Okay? So that's the if block. Again, you always have, you can have as many else if block as you want. If A is true, then go here, otherwise go here, else you keep going until the end. And usually the last one is the else part. This is sometimes you may not have to use the else part. This is like the catch-all. And if you don't need to supply that, then it will skip it, and you don't have to return anything. But sometimes you want to return a default value if none of the above is true. Okay, so this is the else part. And then, and notice also I don't wrap the this block with the curly braces. Typically you put the curly braces here, and then you put it here, okay, for each block. And you should do that because so that you know which block of code goes where. And remember we talked about block last time. This is a block scope, and it's a block scope. Okay. If you have only one line after the if block or the else if block, you don't have to use the curly braces. Okay, it's optional. It will know it by default. But if you're going to use two lines or more, then you have to wrap it with the curly braces. If you don't do that, then it will assume that that's part of the next block. Okay? So if I do this, for example, if I say if grade is 100, then I'm going to say return A plus. And also, if I think that also return, return something like, if I say, system out, for example, print, yay, whatever, right? If you do this, and notice again the IDE already kind of helps you here, it indents it back to the left column. If I were to do this, and I think that I want this to be a part of this if block here. If this is true, then, well, instead of, maybe not that part, but do this. Then write the system out, say yay, and then return grade A. Okay? If you don't put the color braces here, then it will stop here. The if block ends here, and then you have an error because this belongs to nobody. If they are a part of the if block, then you have to wrap it with the curly braces, saying these two statements belong to this if block. Okay, so make sure you have you kind of like match your color braces, put them together in one block of code, and to prevent some type of this kind of errors here. And sometimes you would have these issues, especially you don't have this kind of ID to help you out. You will run into those issues. Well, returning is something else, is different. But if I were to say, if I don't do return, if I say here, if I put int a is 5, and I expect that to be inside part of the if block. Okay, if I don't put the color braces, then this will be on a separate own statement, and it will execute even if this is true or false. It doesn't matter if it's true or false, this will run anyway, because this is the same thing as saying it's by itself. Okay, so you want to make sure you include that inside the block if you want that to be inside of that block of code. Okay. All right, so that's the if and else block. I want to write another function here. Okay, public static string type, just get grade, get final grade. I'm going to pass grade also. And so this time I'm going to use the switch. So this is the switch block. The switch block is kind of similar to the if blocks. Notice I have like, if this is true, then do that, else if that's true, do that, else if this, do that, else do that, right? Okay. You can do the same thing inside the switch block here. So the switch is like you had the syntax. So you switch what goes in here is this grade. You test for the grade. It's like you reach your hand to a basket of cards or marble, whatever it is. You pick that card out and you see the number what that grade is. Okay, if it's a 97, then do something like that, right? So let's just say we'll do like and again in the probably beginning here, the switch here. So with all these if and else, you could use the switch block to do something like that. So I'm switching the grade or the year, and I'm going to test the first case. If the year equals 1, right, or year is equal to 2017, or grade equals, if it's 90, then I'm going to execute these statements here. And then a break means stop here, and then exit out the switch block. Don't continue on. So it's like the first if block. If this is true, then do this, and then else if that's not true, then do the second case, else do the third case, fourth case, and then the default is like the else part. Okay, it's the catch-all. If you don't put a break inside each of these cases, that means that it's going to test all of them, whether it matches or not. I mean from the one that is true. So if you take out the break for 2, and if the year is 2, then it's going to run to 2, 3, 4, all the way to default. Okay. So if you want to just exit out after you read it matches 2, then put the break here, and it will exit out the switch, and you'll be done with that. So that's the difference between the switch and the if block. So here you're testing for the days. This is a string type, and you can only test one data type at a time. You cannot switch a mix and match. Here is a case as a Monday. Then suddenly you test for 3 or 4 or 5. But you can't do that. The day here, whatever this variable type is, has to match the condition here. If it's a string, it has to be a constraint type. If it's an integer, it has to be integer type. If it's a Boolean, it has to be true or false type. Okay. So here is another one here. This means that if the department is a 1, 2, 3, 4, 5, if the number here matches 1, 2, or 3, this is like the OR case. Okay. If 1 or 2 or 3, then that person is supervisor is Jones. If it's a 4, then it's Staples, and then so on. So this is the case where you don't have the break in there, because I could say case 1, supervisor is Jones. Case 2, supervisor is Jones. They're the same thing. So you just put case 1 and then just the colon. It's a blank, empty case statement, and it will run all the way through because we didn't supply the break. It will stop until we read the first break, and then it will exit out, and then we're done with that case. Okay? This is another one. For character, let's see. So if you say grade case, we'll say greater or equal to 97, right? We say. If that's the case, then and we'll put a default down here, and return F. Okay, let's see. This is not right. I don't want 97. Case, let's see, grade. Case, oops. Okay, so you test whether it's greater or equal to 97. This would be int type, double actually. Oh yeah, okay. Yeah, this is one of those situations here. Because double is a decimal number. Okay, one thing you should kind of watch out. Good thing I catch this is that usually it's not preferred to use double or decimal numbers in your switch cases. Okay, because it has a lot of numbers in between. It could be 95.3, 95.1, 2, 3, 4, 5. So it's really hard to do that. And so the switch case is not really meant to use for double values. They usually just characters, strings, or integer values. Okay, so and this is not a good example here. If I were to put grade as a integer, it would be fine. But we'll just do something else. We'll just say, and we'll just have to test a year. Okay, so year is equal to 2016. Then return, past. doesn't like that one. If it's 2017, then we'll return present. And then if it's else, we'll just put future. Okay, so and the reason why you see that I don't put the break is because when you run the return statement here, it's going to exit out of the case automatically anyway. Okay, because it's a string type, you have to return a string type here, and as long as you issue the return statement, it's going to stop here. If you don't, then you have to say something like here. You can have a variable here, maybe like string YR. And then we'll put like blank here, and then we'll say string YR is equal to past, okay, and then the YR is equal to present, and then return YR is equal to that, and then now we can put the break here. Okay, so we can break it. Again, break it just to exit out that when you're done already. So we're done, exit out. And the last part you don't have to put a break because it's going to be the last one anyway. But still, you have to return something because it's a string type. So at the end, you still have the return statement here. Return the year back. Okay, so you would do that down here, one line in return statement. Inside, you just basically assign the variable here, year to a past, present, and future, and return it. You do it this way, or you can do like I did earlier. You put the return here, and then once you do that, you don't have to put the break anymore because it's going to exit out of the loop anyway. Okay, so this is the case block, and when you run the code down here, I could still say another, string here would be str is to get what I say. How do you change it to something else? Change it to get what do you call this? I don't know, get time or something. Let's just say that. Get time. You gotta pass the year into that function, and then now we can print another line down here. Say, time or something, and we have the string here. And if you run this, you'll see that it's either present because it's taken 2017, 2016 is in the past, and this is also in the present. Okay, so the switch statement sometimes is much easier than the if and else block. As you can see, you have a lot of lines here, right? If else, but with the case, you can see it's much cleaner, much nicer. So again, depending on the situation, probably you can prefer using the switch case. It's much cleaner, and it's easier to see, as well as easier to code. It actually saves you much more lines of code. Okay, I mean, it doesn't work for all cases though. Sometimes only the if-else block will work. Okay, for example, you cannot use like decimal numbers, right? That's not really efficient. So in that case, you have to use the if block. Okay, so I want to talk about how much time do we have left? 15 minutes. So let's talk about this operator called the conditional operator. Okay, this is the and the not. So it takes this syntax here. You do the expression first, so you test the condition if it's true or false, and then you put a question mark after that with a space in between the expression. And if the result is true, then the answer goes into this position, and then you separate that with the semicolon, and the false result goes here. Okay, again, this is the same as saying if A is greater than B, then return A, else return B, right? Same thing. It's just an if and else block. You shorten that into a single line. Okay? So let's see an example here. So back to the grade here again. So let's just do one below here. Or I mean, like down here. Not good, yeah. So what do we do? Let's just do here is fine. Shorter. So I'm going to do a, I'm going to turn all these off. I'm going to comment these out, or use the conditional operator, or sometimes called the ternary operator. Okay, and the syntax is always the expression. If that is true, then true part. Okay, true part here, else false part. Anybody here use Excel? Yeah, do you ever use those formulas in Excel? This is exactly the same, kind of same as that. Okay. So I'm going to say the year, right? Let's say year. If year is greater or equal to, well, let's do this. If year is equal to 2017, okay. So this is the conditional expression here. If year is true, we'll say if year is true, then we'll say year is equal to present. Oops. Else, so I just wanted to year is equal to, let's say past, right? Like that. Okay, so that 4 lines of code can be written this way. Let's say year equals 2017. If that is true, so test the question mark means test that condition. Okay, if it's true, then year is equal to present. Else, year is equal to past. Actually, no, not equal. Year over here, year equals that. Okay? So YR will return either present or past, depending on the condition here. So it's going to test condition. If it's true, then return present. Otherwise, set to past. So we have 4 lines and breaks it down to a single line of code. And you can even have this nested as well. And it gets confusing if you do that, right? So you say, for example, if year is present, if that is true, then they want to do this, for example. You want to test like if year is, you can say like if, let's just say that if, test number here, if 5 is greater than 6, right? If that is true, then I return present. I'm just making some fake data here. Else, year is going to be unknown or something, right? So you have a nested if inside the thing here. So if this is true, there isn't a true part. So here, instead of saying present, I'm going to have the whole thing again here. I put it inside here. Okay, so it gets convoluted, and then you see like, okay, so if this is the other part, I say now if 5 is greater than 6, right? If that is true, then return present. Else, return unknown. Okay, you see it. You see how that goes. You nest it inside. So this is the condition, the if condition here. You test for these 2 numbers. If 5 is greater than 6, so this whole thing is the true part, right? This is the true part. If the year is true, if it matches, then yeah, go in here. And then inside I have another condition part. Right? So I'm going to test another condition. If 5 is greater than 6, then return present, else return unknown. and then I'm done there. If it's not true, then this whole thing is bypassed, and it will just return passed. Okay, so this is how you would rewrite this whole if block here, and with the nested if into a single line that way. And again, it gets convoluted. It gets really twisted. And you can also do the same thing with the other part. If it's false, then you have a nested if and keep going, and it gets really confusing. So again, it's not really ideal to have this kind of situation here. The deepest you can go is probably just this far, 2 layers, that's it. The deeper you go, it's getting really confusing, because now I can do another thing here and put it inside here, right? The true part, I keep going forever. and of course, it gets more confusing. But, so typically you will see this also done by more of the advanced programmers, because it saves you a lot of coding. Saves you a lot of time, and also saves you lines of code. Okay, so when you see that, that's what that means. It's the ternary or the conditional operator, and it's basically just an if and else block. Okay. Okay, so the last part here is the not operator, which is this pound sign, exclamation mark. The not operator is just the opposite of the result. Okay, you take the opposite of the result here. So if for example, if I say year is equal to, well, I mean, in this case, if this is true, then you want to make it false. If it's false, you make it true, right? How do you switch that result? It's basically you put this exclamation mark in front of this condition. Okay, it will evaluate the inside condition for expression here. You check that. If it's true, then this means reverse it to false. If it's false, reverse it to true. Okay, so it's really useful, especially when you use some type of like a switch, right? On off. If you, or a button, like you touch it, it turns on. You touch it, it turns off, like that. So I just basically, if I press it, then switch to off. We use the term not it, right? So I should say I'm not this out, meaning I reverse the value, the result of this expression. So you always put it in front of the expression. So if I say, int sum, or or even Boolean b, to if I say 5 is equal to 6. If that is true, that's not true. But if I put the not in front, then that becomes true, right? Because I will switch the false to true, and vice versa. And again, play with this, and we do it again. Now it goes back to false. So it comes from, you would do the internal evaluation first. If it's false, it sets it to true, or if it's true, then sets it back to false. So you can go back and forth this way. But it's really useful for, again, just switching a switch between, on and off, using like a button type, or something like that. That takes 2 parameters. Okay. Because instead of saying if A is already on, then turn A off and then turn B on. Else, if B is on, then turn A off, or something like that. Instead of doing all those 4 lines, just put the not, and that solves the problem. Okay. So a very good example would be like say like this. If I put like found is equal to true, right? And I want to set the current state. I can say, you would say if found is true, right, then the current state set to false. Else, the current state true. right? So this way you're always switching back and forth between the state. If it's true, the first time you come around it's true, then you say, okay, now it's false. The next time is, well, actually no, this should be like the current state, sorry. You're checking the current state. So initially it's true. Should take this out. So initially it's true, and you test it. If it's true, then switch it to false. The next time you come around is, oh, it's false, so therefore change to true, and so on. So you just kind of toggle between the two states. So instead of doing that, I could just say current state is equal to current state is equal to true. And just basically not it. Okay? So if it's true, then you make it false. If it's false, you make it true. So I can write, change all these 4 lines into a single line this way. So it's a shortcut. Okay, so this is also very useful, especially for this kind of situation here. All right, I think that's it for this one. And I'm just going to talk one last thing about the assignments for this unit. So I'm not going to ask you to do you do it for this chapter because I think it's it's pretty straightforward. I mean, you can do if you want. Okay, it's good practice. Okay, so basically we're doing the exercise of 3 and 7, and it's a really short exercises, and then that's it for this chapter. And of course, I know you have the Unit 4 project, but hopefully the earlier examples help you out. If it's not, again, if you're stuck anywhere, please don't hesitate to send me an email. And unless you have any questions, I think we're done for today. Okay.